Hello everyone, this video is about the solution of worksheet number 10. As the first question, it says differentiate and simplify if possible. So we know that number one is an exponential function with base e, and for taking derivative for dy dx, we would write it as a copy of whatever we have, like cosine of x minus 3 times d dx of the power, which is cosine of x minus 3. So we would keep the first one as it is, and we know that derivative of cosine is minus sine of x, and the derivative of negative 3 is 0. So altogether it will be negative sine of x times e to the power cosine of x minus 3. Number two is about um, a function, actually two functions that are multiplied together. And the first one does not have any power, the second one has power 6. So to take derivative, we would write and consider the whole graph here, the overall function here. So we would see that we have two parts that are multiplied together. In this case, we're going to use product rule. So dy dx would be copy the first one, derivative of the second one, which is ddx of sine of x minus 5 power 6 plus copy the second one, which is sine of x minus 5 power 6, and then derivative of the first one, which is 3x plus 2. So we know that we would copy the first one as it is, and derivative of the second one is basically a power function. So we would move power to the front. We would write the same expression with power 1 less, which is 5, and the derivative of the inside, which is sine of x minus 5. Plus, for the second part, we would rewrite sine of x minus 5 power 6, and derivative of 3x plus 2 is just 3. So we would rewrite everything. 6, we usually write it at first. 3x plus 2 times sine of x minus 5 to the power 5, and we know that derivative of sine is cosine of x, and derivative of negative 5 is 0. So altogether, this will be written as this expression. And since it says simplify if possible, we can factor out sine of x minus 5 to the power 5, and also we can factor out 3 here. So we are left with 2 times 3x plus 2 times cosine of x from the first one, and sine of x minus 5 from the second one. And we can rewrite it here. Also, you can multiply 2 into 3x plus 2. You would get 6x plus 4. And we have a negative 5 here. So we would write it as 6x plus, oh, sorry. 6x plus 4 times cosine of x plus sine of x minus 5 here. And this is multiplied to the whole thing. You can simplify this as you see here. Let's move on to number 3. Number 3, the overall function is a power function, which is to the power 4. So we would start with a power function. It will be dy dx equals, we would bring the power to the front, we would rewrite the expression to the power 1 less, and then derivative of the inside, which is x plus 1, 9x minus 5. So 4 times x plus 1, 9x minus 5, we just rewrite them. And this part is the derivative of a quotient. So we would write the top, we would write the derivative of the top, which is 1 times the numerator, times the denominator minus derivative of the numerator times to the top all over 9x minus 5 to the power 2. And we can simplify this as x plus 1, 9x minus 5 to the power 3 here, multiplied by the denominator remains the same, and the top we will have 9x minus 5 minus 9x plus 9. So these two will cancel out, and we're left with x plus 1 power 3 over 9x minus 5 power 3, and we have a power 2 here, so altogether power 5 to the 4, because this part, 9x and 9x are just canceled out, and negative 5 plus 9 is 4. So altogether, you would end up with 16 times x plus 1 power 3 over 9x minus 5 power 5. Okay, number 5. Number 4. Number 4 is a product rule. So since we have two parts, both parts have variables, so we would find the derivative using product rule. We would copy the first one, which is cube root of x squared plus 1, derivative of the second part, plus copy the second part, and derivative of the first part, which is cube root of x to the power 2 plus 1. So we can write it as power function, or you can simply keep it as it is now. So what is the derivative of 3? That is 0. The derivative of tangent is secant squared, but we have a negative here, so negative secant squared, plus 3 minus tan x times, for this part, you can rewrite it as x to the power 2 over 3. And if you do this, you can take derivative, that would be 2 over 3 times x to the power 2 over 3 minus 1, which is negative 1 over 3. And we know that the derivative of 1 is just 0. So you can rewrite it as cube root of x squared plus 1 times negative secant squared of x plus 3 minus tan x, which is multiplied by 2 over 3. And since it is negative, you would write it as 1 over cube root of x. Number 5 is an exponential function with base e. So for finding the derivative, we would write a copy of this multiplied by derivative of the power, which is cosecant 3 theta. So keep the first one, And the derivative of cosecant 3 theta would be cosecant 3 theta, cotan 3 theta, and derivative of 3 theta, because it is not theta, it is 3 theta. And we know that the derivative of 3 theta is just 3, so we would rewrite everything here as the answer. Cosecant 3 theta, cotangent 3 theta. And this was the solution for number 5. Let's move on to the next page. Number 6 is about taking derivative of cosine of tan x. So the overall function here is just cosine function. We know that for cosine function, the derivative is negative sine of whatever we have times derivative of the inside, which is tan here. So negative sine of tan is written again, and we know that the derivative of tan is secant squared. And it cannot be simplified anymore. Number 7 is about 4 to the power sine of x. It is an exponential function, so dy dx would be a copy of whatever we have times the derivative of the power times ln of the base, because the base is not e here. If it was e, we don't write ln because ln of e is just 1. So altogether, it will be 4 to the power sine of x times ln of 4 times, we know that the derivative of sine is cosine of x. Next one is almost the same, but the power is sine squared. So dy dx will have a copy of whatever we have times the derivative of the power, which is sine squared here, and multiplied by ln of 4. So we have 4 to the power sine squared of x, we have ln of 4, and for taking derivative of sine squared, since the overall function here is a power function, you would write it as 2 sine of x to the power 1 less, which is 1, and derivative of sine. So we know that the derivative of sine is cosine. Altogether, it will be 4 power sine squared of x ln of x times 2 sine of x cosine of x. And you can rewrite this part as sine of double x, but it is optional. You can leave it as is. Let's move on to number 9. Number 9 here. Number 9, we have 3e to the t. So we have a part here and we have another part here. Both parts have a variable. So we have to do product rule. dy dx. You can keep 3 out of it, or you can have that with the first part. Either is fine. So if I put 3 out, I would write copy the first one, derivative of the second one, plus copy the second one, and derivative of the first one. Okay, so this one should be t, not x. So t here, t here, t here. dy dt would be 3 times e to the t derivative of cosine 3t is negative sine of 3t derivative of the inside, which is 3t, plus cosine of 3t times derivative of e to the t, which is itself. So everything remains the same, but instead of this part, we have 3. So 3e to the t, and we can put the negative here, sine of 3t plus e to the t cosine of 3t. And also you can factor out 3. So you can write it as 3 times 3e to the t times negative 3 sine of 3t plus cosine of 3t. Number 10 is sine of something. So the overall function here is sine. We know that for taking derivative of sine, that would be cosine of whatever we have, derivative, and we know that x is the variable here, of a squared plus x squared. So dy dx would be cosine of a squared plus x squared times derivative of a squared when a is not variable is 0, and derivative of x squared when x is variable, it will be 2 times x. Number 11 is again a product rule. So we would copy the first one, derivative of the second one, plus copy the second one, derivative of the first one. It will be x, and we know that derivative of e to the x is a copy of that times derivative of the power plus, and we know that the derivative of x is just 1. So, and derivative of negative 3x is negative 3. We would rewrite it as this part, and we can factor out e to the power negative 3x from the whole thing, and we're left with negative 3x plus 1. Number 12. Number 12 here. Number 12 is sine function. So dy dx would be cosine of whatever you have times the derivative of the inside. So it will be cosine x squared times 2x. But number 13 is sine of x to the power 2. So if this one is the same as sine of x to the power 2. This one is not sine as the overall function. It is a power function. So for finding the derivative here, we would consider it as a power function. So we would have dy dx equals, since it is power function, we bring the power down, and sine of x to the power 1 less, which is 1, and derivative of the inside, which is sine of x. Now we know that the derivative of sine is cosine, so it will be 2 times sine of x cosine of x, and we can rewrite it as 2, not 2, sine of 2x. Next page, it will be number 14 here. It is secant. So the overall function here is secant. dy dx. The derivative of secant as a function is secant tangent. But in here, we don't have just x. We have secant of tan 3x. So we would write secant of whatever we have times tan of whatever we have times derivative of inside, which is derivative of tan 3x. So secant tan 3x tan of tan 3x will be rewritten here, and derivative of tan 3x is secant squared of whatever you have times the derivative of the inside, which is 3x. So we know that derivative of 3x is 3. We would write the number here as a coefficient, and the rest will be rewritten as the final answer. Okay. Number 15 is e to the x plus e to negative x over 2. You may think of quotient rule here, but it is not quotient rule because we don't have variable in the denominator. So we would rewrite it as 1 over 2 times e to the x plus e to negative x. Also, you can rewrite that 1 over 2 e to the x plus 1 over 2 e to negative x. To e to negative x. Or you can simply keep it as 1 over 2 times e to the x plus e to negative x. It all depends on you. So dy dx will be 1 over 2 derivative of e to the x, which is e to the x, plus 1 over 2 derivative of e to negative x, which is negative e to negative x. And you can factor out 1 over 2 and write it as e to the x minus e to negative x, or you can write it as e to the x minus e to negative x all over 2. Either is fine. Number 16, find an equation of the tangent line and normal line to the curve y equals square root of 1 plus x squared at a point 0 and 1. So for taking derivative, because we know that for writing tangent line, we need a slope, and slope is the derivative. It will be, you can rewrite it as 1 plus x squared power 1 over 2 and treat it as power function. So you can write it as 1 over 2, 1 plus x squared to the power 1 less, which is negative 1 over 2, times the derivative of the inside, which is 2x. Altogether, you would have x over square root of 1 plus x squared, because it will be 2 and 2 here, and these will cancel out. And the point is x equals 0 and y equals 1. So by replacing x equals 0, it will be 0 over square root of 1 plus 0. It is not undefined, it is defined. It is 0 over a number which is 0. So slope of tangent line is 0. We can write the equation of the tangent line here by using the slope and the point that we have. So the slope of tangent line is 0. So slope of tangent line is 0. And the point is 0 and 1. Using the formula, we would write it as y minus y sub 1, here is 1, equals m, which is 0, times x minus 0. If we simplify, we would get y minus 1 equals 0, and it will be y equals 1 as the slope, as the tangent line. We know that y equals 0 is a horizontal line. So for finding the slope of normal line, we would find negative 1 over slope of tangent line, which is 0. We know that this way of writing is not correct, but we know that 1 over 0 is infinity. So in this case, the slope of normal line is infinity. And for those lines that the slope is infinity, this will be a vertical line depending on the x. So in this case, x equals 0 is the normal line. Number 17. Please pause the video and read the question and then follow the answer. It says use the reciprocal rule or quotient rule because it is easier to use reciprocal rule. But you can also find quotient rule, although that the top doesn't have variable, but since it is 1 over something or 61, a number over something, you can use it as quotient rule. But I think that reciprocal rule is easier. Following the reciprocal rule, P prime of t will be a line. At the top, you would write the derivative, and at the bottom, you would write as the function as is, or you can follow quotient rule. It's up to you. So either method is fine. So you would end up this formula as the quotient. 1 plus 3e to the power negative 0.794. Okay, let me correct it. 7,944 all to the power 2 times derivative, because of the reciprocal rule, that would be derivative over the function itself. And also that reciprocal rule is when you have 1 over a function, but this one is 61 over a function. So we would multiply 61 to it. dx as the derivative of the function. The function is 1 plus 31 e to the power negative 0.794 for t. So altogether, p prime of t will be, so finding derivative, this part, you would keep 31 as the coefficient. You would multiply it as a copy of the function that you have and also multiply by the derivative of the power, which is negative 0.7944t. So we would have negative 61 times 31 times negative 0.7944 and a copy of that, which is negative 0.7944t all over 1 plus 3e to the power negative 0.7944 t to the power 2. There is a t here also. So if we multiply them, we would get 1502 times e to the power negative 0.7794 t all over 1 plus e to the power, 31 e to the power negative 0.7944 t power 2. Now we would replace 8 for t. So if you do this and use calculator, you would end up with 2.35. That is the speed because the derivative of the logistic function is the speed of that, and after 8 days would be this much. Let's move on to 18. It says find dy dx by implicit differentiation. For implicit differentiation, whenever we have y, we would consider that y is a function in terms of x. So for cosine, it will be negative sine of whatever you have multiplied by d dx of the inside, which is x squared times y. So we would keep 1 plus x here. We would rewrite negative sine of x squared y. And we know that for this part, we would have product rule. We would copy the first one, derivative of the second one, which is y prime, and copy the second one, derivative of the first one. And the goal is finding y prime. So you have to multiply this, you would get negative x squared y prime sine of x squared y plus minus 2xy sine of x squared y and we would find y prime. It will be 1 plus x plus 2xy sine of x squared y over negative x squared sine of x squared y. Next one, number 19, is another function which is written here. So let me erase the board. This one, when you want to find the derivative, when you have x, you do it as usual. So it will be 12x to the power 3 minus 5. But for the third term, since it is y cubed times x, you would write it as 7 times, copy the first one, derivative of the second one, which is 1, plus copy the second one, and derivative of the first one, which is 3y squared times y prime here, minus, same thing for the next part, which is 2 times, copy the first one, derivative of the second one, y prime, plus copy the second one, derivative of the first one, which is 1, equals 5. So you would multiply this and you would simplify and you would end up with 2y minus 7y cubed plus 5 minus 12x squared x cubed over 21y squared minus 2x. And number 20 here, please again pause the video, read the question, and then continue. So for this one, P of t is written as this expression, and in order to find the derivative, we would write it as P prime of t equals 1/436 times the function. So it will be 1/436 times the function itself, power t, and ln of the base, which is ln of 1.01345. And for P of 1920, which is 20 years after 1900, you would plug in for that and you end up with 26.25 million years. And for next one, which is 1950, it is 50 years after 1900. So you would plug in for 50, of course, for P prime, and it will be approximately 39.78 million years.